Core system login in progress.
Now, post evaluate is a little annoying. It's kind of some redundant code or some duplicate code, but it's necessary. Although we're using .NET, .NET is still assigning stuff on the heap in the stack. It's still having to find space. And I just find this method the most friendly to that. See, our V count. So first of all, I'm resizing my temporary vertices to the number of vertices we used. And now I'm going to copy that number of vertices over. Why don't we just resize the vertices in to this size and then resize them back again? Because our vertices, the reason is our vertices is a much larger array normally. It's sized to try to take care of everything. The number of vertices that we use will be smaller in most instances, except when we break. So it's such a, it may seem like such a minute savings of RAM, but in the end, it's actually a lot of savings of RAM, because it's really, there's probably normally going to be a very big spread between the number of vertices we actually use and the number of vertices we allow. And we're really trying to save RAM anywhere we can. So copy that first one and paste it down here twice. Change this one to temp normals. Change this one temp UVs. Now we've got to go through and do our face indexes. And if our evaluate group face indexes was used, we're going to do one thing. Else we'll set our evaluate group temp face index groups used equals to false. We do that because other chunks will be using the same evaluate group, and it may have turned it on, and we want to turn it off now, but we don't want to reset those if we don't have to. Now this is almost the same piece of code as above, but it's just longer. And if I remember correctly, Microsoft's system array stuff is done in native code, so it's pretty hard to beat. I actually did some benchmarking one time, and I couldn't beat it if I didn't go to native code myself and write a library for native imports. And then I could only beat it by a fraction, even with tightly casting everything. Now we're finally getting to our create meshes. So if our current n on our create results is greater than the number of game objects we have, then we need a new game object. And later on, we have got to get rid of new game objects that we created but now need to delete because we have erased stuff from our screen. So we're setting up here for the future. And we'll have multi-chunks, although we're really only working with one lonely little chunk right now. And we will go over to using Unity's draw mesh function, first having a mesh filter. When we go to put the shaders into place for the tiling, I find it easier to work with the materials property object with the GL stuff. But we don't want to actually go through and draw each face individually. So we will simply use the graphics draw. Not the before I said GL, I meant graphics. But we'll use the graphics draw mesh later on. And for our first chunk, for our lonely chunk, there's almost zero chance, well, there is zero chance of it having a null value on the mesh. But the old man in me just wants me to do the null check. So I'm just going to humor him now. But if it's not null, then we'll clear it. And set everything here. And what you did that for, Microsoft? Okay. Now, since we're using sub meshes, we will need a material array. Atlases are great, but they're not great for development. And if you can't use an atlas, and don't worry about it, just don't use it. You see some people in the forums and the help websites and on Stack Overflow, they just give up because they cannot use an atlas. I didn't say material presets. So we are using a double indexer here. Checking on our end, getting from our end, but we're actually not setting every end, so we have to have an M or another indexer. I use M because I normally use I somewhere else. Put that. We will import our tangents from Blender when we get to the mesh library. But for the moment, we'll let Unity recalculate them. And they're only really important, tangents are only really important if you have a normal map. I don't know if they do affect, or yeah, I don't think they affect the height map. But they do, well, I guess they would have to affect the height map. But since we're using plain colors, tangents are really not important to us right now. But you may want to play around with materials. So let's put that there. If you don't have the calculate tangents on there and you have a normal map, you can really see the difference, because on certain sides of our block it will be totally smooth. The normals or in the height map will not affect it. Alright, so we now need to create the CreateMesh1 function. I believe that's our last function right now. Yeah, it is. And it is very empty right now. And we'll just go to the paused state for right now. Okay. And you know I almost always do a typo somewhere, so I'm not really lying to myself at all. I'm checking my code. Okay, so we need to go up here and initialize everything in the start, and then we will actually put our simple state machine into play down here in the update. So up in the start, we have some code to add. We know there's going to be no children here, so it'll be child 0. set our origins. Although we only have one chunk, we can set our column or row of that chunk to other values and get different results. In our base shape, since it is a scriptable object, it will need to be created here. Okay. Now we're going to do our state machine. And we'll be ready to jump to the front. Back to Unity. So in this case, I'm setting each of my functions to the ing version. We haven't brought in the task yet to do the multi-threading. We'll be using a Microsoft example that works really well. Lets us control how many threads we're going to use. Puts everything in a nice queue so we don't have to think about it. What am I doing here? Not right. But most of these functions, other than the create meshes, will be on a child. Thread. Never liked that name, child thread. And we can turn the CreateMesh into a coroutine if we need to. Experimented with it, and I didn't really see any performance gain. So and that's about it. Okay, now to the front end.